motors, we have single phase and three phase. The symbol for a phase is a circle with a slash through it. As you can see, I'm not a very good artist, but in my renderings here, on a single phase motor, we have two poles 180 degrees apart. If you took a pencil or something and you held your hands directly across from each other and you applied pressure on it, you'll see that it becomes a brake. It doesn't want to rotate. So how do we make a single phase motor turn? Well, we have to physically move one of these pressure points. And how do we do that? Well, it's on timing. So if we go back to my original thing of inductive reactance and inductive capacitance, if we look at capacitance and we think of a capacitor as a bucket, if we take a water hose and the water hose is filling a 5-gallon bucket, the water level is going to rise, and that's going to take a certain amount of time. Then it's going to overflow. So what would take place is we have power going directly to one. We put a capacitor in here, and initially when the motor first starts up, it doesn't get power here. It has to wait until the bucket fills up. The bucket fills up, and basically it takes and moves us backwards a little bit. And now we're over here someplace. So now we take one finger and we apply it slightly above the other and we rotate. So we have, that's one way. We have another way of doing it. When you'll see that on the cheap little bathroom fans, you'll see like this one big loop. They call it a shaded pole. Well, there's two ways we can have the timing of this change. One is by capacitor. The capacitor is going to fill the bucket up till the bucket overflows, and then the electricity comes out of it. Or this guy here, this is an analogy, so it's not exact math here. Let's say we go 10 feet with this guy, and then this guy here we go 2,000 feet. Who's going to get there first? The guy that goes the shorter distance. All things being the same, they're going to go the exact same speed. So what they do is they take and they make one guy go a lot further than the other to get there, and that will pull him over. On the shaded pole motor, the timing of it is so little that you have very, very little starting torque. That's why you only see it on like cheap bathroom fans and stuff. Permanent split capacitor motors have more torque, and then for single phase motors, the other one you'll have is an induction motor, which is actually two motors. They'll have a start motor and a run motor, and at the end of it there's a switch that has bulbs on it that go out that act as a clutch, that when the motor gets to 3/4 of its speed, it shifts gears, and when it shifts gears, it shuts off the start motor. And for the start motor, they literally take and say, oh, well, let's put another set of leads on here, and we'll put it at a different angle so that we can get this thing to roll. And now you get more starting torque. So this brings us to three-phase motors and why they're superior. Three-phase motors, they're 120 degrees apart. So it just, as soon as you turn it on, it's full torque. It's spinning smooth. Everything is trying to make a circle because it's 120 degrees out of phase. If you lose one phase on a single phase, a three-phase motor, now with having two points pushing at 120 degrees like this, it just tries to smash the motor up through the other end of the casing, and it doesn't turn because you have two things pushing up and nothing pushing down, so it doesn't rotate. All it does is lift. So if I have pressure on two sides here, all I do is I lift the motor up, and
so it's immediately
tries to just lock up the motor. It becomes a brake, and you burn up the motor.
What about bad rotation, like wrong rotation?
Well, for rotation, it's a matter of you change any two leads, and basically, all it's doing is you think about it as okay, you have only three ways you can go north, south, north, south. So if we got south, north, south, it's going to go one direction. If you go the opposite of that, because you took and swapped the leads around, now I forget what I just said. If you had south, north, south, and then you went north, south, north, you have two norths and one south. It's going to spin the other direction. And that's why they swap. If you swap any two leads, it'll change direction on a three-phase motor. On a single-phase motor, you have to interchange the way the capacitor is to the windings on who has what. And we'll go over that in a minute.